Hey guys, welcome back to my channel where we explore interesting math problems. Today, we'll be looking at a cool number-based problem. So the question reads, the sequence below consists of the powers of 3 or the sum of distinct powers of 3 arranged in increasing order. Find the 100th term of the sequence. So, the sum of distinct powers of 3 might sound a bit confusing, so I'll break it down. 1 is just 3 to the 0th power. 3 is just 3 to the first power. Then 4 is here because it's 3 to the first power plus 3 to the 0th power. 9 is 3 to the second power. 10 is 3 to the second power plus 3 to the 0th power. And you get the idea. We're basically adding up powers of 3 so that the sequence is increasing. But to solve this question, first we need to understand something called number bases. An example is that our number system is base 10, and each digit could be anything ranging from 0 to 9. So if we have base 3, then each digit could range from 0 to 2. Notice that the maximum number is always 1 less than the number base. There's another important pattern with number bases. So let's tilt this base 10 number on its side, and let's say that the last number is 3. Then each of these digits represent these respective values. Now let's compare with base 3. Again, we tilt this number on its side and we let the last digit be 2. Then it will represent these values respectively. You can observe that for both is the digit value multiplying by the base number to a certain power. And these powers go in decreasing order until you get 0. Now let's do a small exercise with base 3. So if we were to convert this to base 10, we can use what we learned previously and multiply each digit by the number base 3 in descending powers until you get 0. Simplifying, we get that this is 47 in base 10. Now that we've learned a bit about how base 3 works, let's get back to our question. Since the sequence is adding up powers of 3, we can easily represent it with a base 3 number system. Moreover, since the sequence isn't multiplying anything to the powers of 3, it's just multiplying by 1 or 0, so each digit in base 3 will be either 0 or 1. Let's see how it looks. And let's just verify a few of them to prove that's right. So 1 is equal to 3 to the 0th power. 3 is equal to 3 to the first power. 4 is equal to 3 to the first power plus 3 to the 0th power, and so on. Having realized the connection between this sequence and the base 3 numbers, we're ready to solve the question. So looking at the sequence, notice how all the digits only have 0 or 1, which looks a bit like binary. Binary is just a number system with base 2, so it only has zeros and 1. And in fact, if I were to copy this sequence exactly and change the base to binary instead, something really cool happens. A conversion of these binary numbers to base 10 will show that this binary sequence is just the natural numbers going from 1, 2, 3, 4, 5, and on. This gives us a very important insight. To find the 100th number in this sequence with base 3, we'll just have to find the 100th number in this sequence with base 2, which just means 100 in base 10. So working backward, we just need to convert 100 to binary first. A good way to do that is with a table like this. Each column represents a digit, and these values are what each digit represents. The blanks down here represent how many of these you can fit in 100. And I'll just give you the result. So now we know 100 is this huge number in base 2. So we also know the number we want in base 3. But remember, what we're really looking for is the 100th term in this sequence, which is in base 10. this sequence is just a representation of this in base 3. So all we have to do is convert this to base 10. Like before, we multiply the digit number by the base to a certain power, ignoring the zeros here and evaluating the expression, we get 981, and that's our answer. Okay, that's it everyone. Thanks for watching and we'll see you next time.